One good day, summer pre-algebra. This is your crash course for what was covered on Monday, June 13th. I'm going to try and keep these videos to about, 5 to 10 minutes, since I know watching a longer one can be kind of tedious and dull, get distracted. So I'll try to hit the high points, and just if you need to catch up with me during class later on, then we can certainly do that. So today we talked about greatest common factor. It is a number that goes into another number evenly. For example, the factors of 12 would be 1 and 12, 2 and 6, and 3 and 4, right? 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. 7 would not be a factor of 12, for example, because it doesn't go into 12 evenly. Okay? 10 would not be a factor because 10 doesn't go into 12 evenly. Okay? Nothing greater than 12 can be a factor because nothing greater than 12, again, can go into 12 evenly. Okay? One method that we talked about to find the greatest common factor of a set of numbers is the listing method. You're probably familiar with this if you've done greatest common factor before. Basically, it involves listing the factors of each given number, figure out which factors are common, and then mirror on the wall which is greatest of them all. The greatest of the common factors is going to be the GCF. So if you need these notes, jot them down, pause the video, go ahead and do that. We are going to jump right into an example. With 40 and 72, so using the listing method, we are simply going to list the factors of 40 and list the factors of 72. So for 40, we have 1 and 40, 2 and 20, 4 and 10, 5 and 8. For 72, we've got 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Okay. So the big disadvantage that we talked about with the listing method is that if you're not so comfortable or familiar with your factors, with your multiplication tables, this is going to be challenging because you might, miss the factor pair that you need. But we've got them all out here, and now we're going to identify the common factors. They each have a 1 and a 2 and a 4, and they each have an 8. And what is the greatest of those common factors? Well, the greatest common factor is 8. Okay? And that would be how we get our answer there. The second method, which above lists prime factorization, but I stumbled across a different method that students tend to like better. And I don't know what to call it, the chart method? I don't know. Maybe you can come up with one. But it basically involves making a little chart or table here. And we're going to put 40 and 72 across the top. And in that upper left section, I want a number that goes into both 40 and 72. So the advantage here is you don't have to know every factor pair of both numbers. You just have to know what goes into each of them, a starting point. And they're both even, so we'll start with 2. Okay? And then what you do is you divide 40 by 2 and divide 72 by 2. And the next line of our chart here, 40 divided by 2 is 20. 72 divided by 2 is 36. Okay, we've factored out a 2. We've taken out a 2 of both 40 and 72, and now we've got 20 and 36. And now we look and we say, okay, what's another number that goes into both 20 and 36? We could use 2 again because they're both even, but I do notice that 4 goes into both 20 and 36. I'm going to put a 4 there. And I'm going to divide 20 by 4, divide 36 by 4. And the next line of my chart, 20 divided by 4 is 5, 36 divided by 4 is 9. And at this point, you look at 5 and 9, and the only number that goes into each of them evenly is 1. And that's what we like. Once we get down to this step here, where 1 is the only remaining common factor, then we're finished. And our greatest common factor comes from multiplying all of our non-1 numbers from up above. I mean, you could include 1 if you wanted to, because 2 times 4 is the same thing as 2 times 4 times 1. But either way, you get 8, again, which is good, as the greatest common factor of 40 and 72. And then we went ahead and we did this chart method for 12, 30, and 60. So this time we have to make another column here. And we've got 12, 30, and 60 across the top. And again, in that upper left section, we want a number that goes into all three of them. They're all even, so we'll start with 2 again. 1. Okay. Divide each of them by 2, 12 by 2, 30 by 2, 60 by 2. And the next line of our chart, 12 divided by 2 is 6, 30 divided by 2 is 15, and 60 divided by 2 is 30. Well, they're not all even, so I can't just default to 2 again here. But I do notice that 3 goes into 6, 15, and 30. So I'm going to put a 3 here. This time I'm dividing each of them by 3. And so the next line of my table, 6 divided by 3 is 2, 15 divided by 3 is 5, and 30 divided by 3 is 10. And I'm smiling, I'm happy because the only number that goes into 2, 5, and 10 is 1. So I'm done. Okay? Actually, I'm not done yet. My last step is to multiply 2 and 3 together. And the greatest common factor of 12, 30, and 60 is 6. The listing method will work just as well for this, but the more kids use it, the more kids kind of gravitate toward the chart method, just because they don't have to worry about missing one of those factors, or one of those factor pairs. So your assignment, this was on page 9. If you get the notes down, feel free to pause. On page 10, you've got a whole bunch of opportunities to practice. I don't care which method you use, listing or the chart, as long as you show your work. Showing work is a requirement. The reason being, because if you make a mistake, it's a lot easier for me to go back and see where the mistake happened. It's a lot easier for you to go back and see where the mistake happened. If you don't show your work, you might think, oh, I don't understand anything. They're all wrong. Or maybe it's just something really, really small, really easy to fix, but you'll only catch it if you show that work. So showing work is not optional. It is required. Then you've got some word problems on the next page here. For example, this one, you are creating prize bags to give to guests at your birthday party. You have 18 kazoos, 45 fake tattoos, and 36 stickers with famous mathematicians. What is the greatest number of identical prize bags you can make using all the items? Whenever you see those two phrases, identical and all the items, you know you're using greatest common factor. Okay? And regardless of which method that you use, the GCF of 18, 45, and 36 is 9. Okay? We're not done yet. We figured out how many bags we can make, but the second question is, how many fake tattoos will be in each bag? Well, if you have 45 total fake tattoos, and you are dividing those fake tattoos into 9 bags, notice my language saying dividing there, you're dividing them into 9 bags evenly. 45 divided by 9, ta-da! Each bag will get 5 fake tattoos. So it always starts with finding that greatest common factor, but make sure you're answering both questions if there are 2 of them for each question there. So there you go. There's your crash course. I don't know if I kept it to 5 or so minutes, but any questions that you have, my email is open. Otherwise, like I said, we can connect during class. But do what you can. I look forward to seeing you tomorrow. And that's how you math. Don't forget to like and subscribe. Bye.